Today we're looking at lesson 1-6 and we're going to break this up into 2 days. So today we're mainly focusing on translations and reflections, which you had exposure to last year as well. If you recall, a translation is an operation that shifts the graph horizontally or vertically or possibly a combination of both. It results in the graph of the same shape and size, but in a different position. And according to your textbook, when we preserve the same shape and the same size, we call this a rigid transformation. So you may either use your graphing calculator. So I went ahead into my y equals. I've entered the first 3 equations in the left column, absolute value of x, absolute value of x minus 3, absolute value of x plus 2. I'm going to go ahead and graph all of them at the same time. I know my parent function is centered around the origin. There's that plus 2. Notice it shifts up 2, and then in the other one is the down 3. So the first question wants to know what's the relationship between the graphs A and B. The graph has been shifted down 2. Down 3. If I look at the graphs of A and C, that's the graph that shifted up 2. Now I'm going to pause, go ahead and enter the second set of 3 absolute value equations. Alright, I entered those 3 equations. Absolute value of x, again, is centered on the origin. Absolute value of x minus 3 actually shifts it to the right 3. Absolute value of x plus 2 shifted left 2. So let's jot that down. We are shifting right 3, and the one below we shifted left 2. And you probably might already start recalling then what changes in the equation to have an effect on the graph. So if you look at the first one, when we have y equals absolute value of x plus k, we shifted the graph up k units from the parent function. When we had absolute value of x minus k, we shifted down k units from the parent function. So applying that real quick to both of these, absolute value of x plus 1, we know it's a V shape. In this case, we're shifting up 1. Keeping that same opening, we're shifting or moving the slope to the left, and we get the following V. Same thing on the next one. If we go down 1, 2, 3, and 4, keep the same slope to the right, same slope to the left, and we end up with the following graph. On the next 2, if you recall, when we have an h value, which is inside the absolute value, when it's a plus h, we actually shifted the graph left h units. When it was a minus h, we actually shifted the graph right h units. So let's graph these 2. We've got the x plus 3, so we're going to shift left 3. Go ahead and draw in that standard V. The next one we're going to shift right 4. And draw in that standard V. Okay, moving on to the next part of your notes. Now you just have a combination of translations. So we need to write an equation and we're going to go ahead and graph them. We haven't talked about the reflection, so for the moment let's just go ahead and change that to a plus. So this first one says left 3 units, so I'm going 1, 2, 3, and down 2. We're going to write that equation. We have y equals absolute value of x plus 3. Remember, on the inside it's left and right. And then we have down 2 units. Let's go ahead and graph this one on the same. Again, I'm going to start at the origin. It says 1, 2, 3, 4 to the right and up 1. Let's write our equation there. Absolute value of x minus 4 plus 1. And then finally the last one we're going to right 2 and down 1, 2, 3, and 4. So we have x minus 2 and minus 4. So let's go ahead and look at the table that I cut and pasted, and for some reason mine got cut off when I went to print. Hopefully yours doesn't have the same thing. So here's that horizontal translation. If we take the function and we're replacing with x minus c, it's to the right. If we replace it with f plus c, it's to the left. Let's look at the table below it. And it says down here, and I'm just going to write it in over here, y equals the function plus c, and we are going up c units. And I'm going to take this one step further. Let's put the c over here. Just to try and keep it consistent, if I go and rewrite this as y minus c equals f of x, and I'll explain to you here in just a second. If you take a look at the second part of that box, it says f of x minus c, and in this case we shift down. C units. And again, I'm going to write this as y plus c equals the function. Now, why am I doing this? Just to keep everything consistent. Last year you oftentimes learned if it's inside the function, you do the opposite. If it's outside, you do it face value. However, if we rewrite it like this, take a look. Minus c is going to the right, plus c is going to the left. Look at it here. If it's a minus c, so we've replaced y with y minus c, that means it's going up c units. If I look at it this format, y plus c, and I'm going down. So if we're consistent in terms of how we write it, we can always look at the graph will move the opposite of what you see inside that function. And some of you will stick with what they have here, but this is the method that we're going to push for. Okay, continuing on. Now we're going to go take a look at a couple of functions with reflections. I'm going to pause here for just a second to write down some of those equations for you. The second piece that we're talking about is reflections, and again this would be considered rigid because I'm not changing the shape or the size. So I'm entering this equation here and I'm entering this one. And this relates to this rule right here. So I've truly taken the opposite of the entire function, and I should expect a reflection across the x-axis. So let's go ahead and graph them. I'm graphing that first one, and I'm graphing that second one. So again, here is the first one, here is the second one. We can see it is truly a reflection across the x-axis. Let's go take a look at the second set of equations. So here again is my original equation. Here's my new equation, and what I'm trying to show you here is I substituted negative x into both locations here. So negative x to the third is a negative x to the third, 2 times negative x. And notice there's nothing here changing that last term because I'm not plugging in a negative x here. Let's go check out the graphs for this one. In this case, I'm expecting a reflection across the y-axis. Let's go take a look at that graph. So there's my first graph, and there's my second graph. Again, there's that symmetry through the y-axis. Okay, finally I went ahead and did the last rule. So that's when I replace x with negative x, and then I turn around and take the opposite of all of those, and I ended up with the following equation. Y equals x cubed plus 2x plus 1. If you check out the graph, that's a reflection through the origin. So that one goes with this one. A couple things I want to point out. Again, just trying to keep everything consistent. If I turn around and get f by itself, just like we did in the horizontal and vertical translations, notice what that really is f divided by negative 1 equals f of x. Or if you want to look at it as negative y is equal to f of x. So what we did, we replaced y with a negative y. That caused that reflection across the x-axis. If you go take a look at the next one, again, y we haven't changed, but we've replaced x with negative x. That in turn caused a reflection across the y-axis. And again, if you look at the last one, if I again go and solve this for f of x by itself, I divided out that negative 1, I got the following. Negative y equals f of negative x. So I replaced both the x with the negative x, and I replaced y with a negative y. And that's the rule when we are reflecting through the origin. I would keep your notes out as you go to the assignment. Keep your calculator out as well, as it might be some benefit. If you have any issues or concerns, don't hesitate to send me an email, and I will post some comments in the discussion board or videos if needed. Good luck.